Hey guys, I just want to take a minute to clarify a concept from this last video, and the only thing that I really want to do, this is going to be a very quick video, is sort of just explain something. A lot of a lot of textbooks really just start with the idea that the probability density, right, of finding the particle at some position x is the norm squared of the wave function, right? And this is how it starts. And this kind of makes sense, although it seems sometimes a little bit unprompted, right? So what I tried to do is I kind of tried to derive this in a way, showing that starting from our basic superposition postulate, that you can write out this wave function, right? Is in this wave function is the norm squared. And this wave function norm squared will give you the probability density. And you can think about this sort of qualitatively, that if you were to come up with a function to represent the state of a particle, right? Say the function looked like this, right? And then it would, of course, go down to 0, because it has to be normalized, right? But this function, right, if you say the particle is most likely to be about here, right? It's going to most likely be in this area. This is where it has the most probability. But it's also kind of likely to be here and kind of likely to be here. A lot less likely to be here, not super likely to be here, not super likely to be here, right? That seems like a good way to draw out the state of the particle. And indeed, right, if this is the wave function, right, what this is saying is it's saying that the particle is pretty much most likely to be here, then, next most likely to be around here, right, third around this area, right, and then the probability goes off to 0, right? And so that should make sense why we would write the wave function like that. The reason I wanted to write it in terms of the cx is just showing you the relationship between, right, because we knew to start off, just because of our superposition, that this norm squared is the probability density, right? The reason I started with this to get to the wave function is to just show you that the wave function, right, the way to express the state of the particle, all it is it's just writing out these coefficients, the coefficients that tell you, right, the cx, it tells you how likely you are to have that particular value of x, right? It's norm squared, and discrete is the probability. It's norm squared, and continuous would be the probability density, right? The coefficients tell you how likely it is to have a certain value of an observable. What I'm showing you is we can write this wave function. To write out the wave function, all you have to do is graph out how the probability, or the probability amplitudes, right? Graph out sort of, in a way, how likely you are to be at that position, right? Which should make a little bit of intuitive sense. If you were to graph out the state of a particle that has a probability associated with it. Okay, so hopefully that does clear things up. I'm really hoping it does. If not, you can leave a comment down below, and I'll try to fix that.